Welcome back to Math with Miss Reimer. Today we're looking at 10.6 notes, which is two-way tables, specifically interpreting relative frequencies. So first we're going to look at how to build two-way tables from the get-go. So we're going to use the information given in this problem to start filling in my table. So first we know that 90 people in a store were asked. So there were 90 people in the survey. So that's going to go in here for the total. Out of 25 that liked khakis, so 25 people total liked khakis, 15 also liked t-shirts. So out of the 25 total, 15 of them liked t-shirts. There were 55 customers that liked t-shirts overall. So that's going to go here. Based off of these four numbers, I know enough information to fill out the rest of the table. So I know that 55 plus whatever is here, 35, is going to equal 90. I know that 15 plus the 10 is going to equal 25. And then I can do the same thing up and down. I know that 55 minus 15 gives me 40 here. 25 and 10 will give me 35. And 65 has to go here so that all of my rows and columns add up to my totals, which are down here on the edges. Now we're going to do our relative frequencies. So relative frequency is, think of it like percentage, but we're going to leave our answer as a decimal. So of the ones who like jeans and t-shirts, it's 40 out of 90. So when we divide 40 out of 90, that gives us 0.44, 44%, but we leave relative frequencies as decimals. Tank tops would be 25 over 90, which is 28.28 when you divide them out. That adds up to a total of 0.72. There were 15 out of the total 90 for the khakis. That would be 0.17. That adds up to 0.61. And 10 out of 90 here, 4.11. When I do the rest of my addition, this should come out to be 1 in the corner here, maybe a little off depending on your rounding error. Also note that sometimes relative frequencies can be just across the rows or just up and down in the columns instead of out of the total number. So you just have to read carefully. So given that a person likes jeans, what percentage of those also like tank tops? So if a person likes jeans, then I'm only looking at this row in the table. So there are 65 total people who like jeans. What percentage of those also like tank tops? So 25 out of the 65 that like jeans also like tank tops. So that would be about 0.38, but the question is asking for a percentage, so we'll go about 38% of the people who like jeans also like tank tops. Given that a person likes t-shirts, so that would just be this row in the table here, so that's 55 total. There's 55 that like the t-shirts. What percentage also like jeans? So in just this row, the people that like jeans are 40 out of the total who like t-shirts, which is 55. So that gives me about 0.72. And let me double check my multiplication. It looks like yeah, we're actually rounding to 73. And this should be 0.73 here as well. So 73% from there. All right, next up. Treats. The owner of a snow cone stand keeps track of the sizes and flavors sold one afternoon. He sells 125 snow cones in all. So that's going to be my total here. Remember that your totals are along the edges of the table. Of these, 40% were large snow cones, 32% were grape, and 12% were small watermelon snow cones. The stand sold 15 more cherry than grape. The most popular snow cone of the day was a small cherry with a total of 35 sales. So let's work on what we have so far. So small cherry with a total of 35 sales, that'll be here. I have a bunch of percentages that I know, and I also know that 15 more cherry than grape. Well, I can't do anything with that information yet, but I can definitely work on these percentages. So 40% were large snow cones. So that means I can take my 125, multiply it by 0.40, and get 50 total. So I know that there are 50 large snow cones total, and that takes care of this percentage right here. 32% were grape, so that's 40. Takes care of that one. And 12% were small. So that's going to give me 15. So 15 of them were small. Take care of that. So now 15 more cherry than grape. Well, if I know that there's 15 more cherry than grape, Then if I know there's 40 total for grape, 15 more cherry than grape would make this 55. So I've used that number as well. And so it looks like I've used all the numbers that they've given me so far. So now I can start to do some addition to figure out the rest. So I know 55 and 40 plus whatever goes here has to equal 125. So that will be 30. And let's see, what else do I know here? So turns out I put my 15 in the wrong spot. So my 12% that were small watermelon was 15 snow cones, which should go in this box right here. That being there, it gives me some more options of things I can start filling in. So this box plus 50 has to equal 125. So that'll be 75 here. 15 and 15 will give me 30. 35, 15, and 25 total has to equal 75. 25 plus 15 will equal 40, and 35 plus 20 will equal 55. Now we're going to do our relative frequencies, and so we'll find those by dividing each of these numbers out of 125. So 35 out of 125 will give me 0.28. 25 out of 125 will give me 0.20. 15 will give me 0.12. I know that this one's also 0.12, as is this one, because they're all 15s. And up here at the top, 20 out of 125, when I put that as decimal, will give me 0.16. Now I can add across my rows to get my totals, and we will get a nice 1 at the end for my total, which is what I should be getting. It might be a little off because of rounding error, depending on how nice your percentages are. But these are now your relative frequencies. Remember, relative frequencies kind of put things in percents. And so there we are for that. All right, so that's building two-way tables. Now we're going to go back, or not go back, we're going to go forward into working with tables that are already formed and answering some questions about them. So Ryan asked a sample of 20 of his friends about what movies they've watched in the last month. The results of his survey are shown in the relative frequency table below. So these are all relative frequencies right now, and we're trying to figure out how many friends actually answered in each category. So from the get-go, you know that 20 is what the total is. And if these are relative frequency, then if I multiply each of these relative frequencies by 20, I'll get back to what I started with. So for instance, in the first one, if I do 0.4, or 0.40 times 20, that will be 8 people. So as I continue through, 25% of 20 is 5. 65, you can add these two together to get 13. 5% of 20 will just be 1 person. 0.30 times 20, or 30%, would be 6. And then I can add across to fill in the rest of my table. Allison interviews her classmates about whether they wear glasses or contacts. The results of her survey are shown in relative frequency. There are 6 more students who do not wear glasses or contacts than who wear glasses but no contacts. So let's look for those relative frequencies first. So who do not wear glasses or contacts would be the 0.44, and glasses but no contacts would be 0.20. So in order to get these two to equal out, there's 6 more in this category. So I need to find the total students that were sampled, which means that I need to know how many were in the survey. So if I can get these two to equal each other, I'm going to take this 6, add it to the 0.20, which is the smaller one, and then these two will be equal. So we'll do 0.44x, so 44% of the total that were sampled has to equal the 20% of those who were sampled plus the 6 students, because there's 6 more that belong to this group than this group. So if I add the 6 to the smaller relative frequency, these two are now equivalent. I can solve this equation by subtracting 0.20 from both sides, which will give me 0.24, x equals 6. And when I divide by 0.24, I will end up with x equaling 25, and this is the total students. So that is the answer to part A. 25 students total were sampled. How many total students were contacts? The total contact number is 0.64 times the 25 total that were surveyed. Oh, wait a minute, I took the wrong one. I did the no contact. So I could find that and then subtract, but it's going to be easier to just use the 0.36 of 25, and that will give me 9 students that wear contacts. And do not wear glasses. No glasses would be 0.56. So that'll be 0.56 times 25, which will give me 14. So that's 14 students who don't wear glasses at all. Oh, there you go. All right, and lastly, Casey asked a random sample of students at his school about their natural hair and eye color. The results of his survey are shown in the relative frequency table. In this sample, there are 44 more students with brown hair and brown eyes than blonde hair and blue eyes. How many students have red hair is the actual question that we're answering. But in order to answer that question, I have to know how many students were surveyed. So I can use this information here to figure that out. So students with brown hair and brown eyes are going to be a 0.350 relative frequency. And blonde hair and blue eyes is going to be 0.075 relative frequency. And there's 44 more in this category than in this one. So if I set these up equal to each other, in order to actually get them to be equivalent, I've got to add the 44 to the smaller amount so that it actually evens out. So if I solve this equation, just like I did in the previous problem, we'll get 0.275x equals 44, divide by 0.275, and we'll get x equals 160 students total. So that's how many who were surveyed. So if that's how many who were surveyed, the total that have red hair, that's what I'm actually looking for, and that is the 0.05. So I'll take the 0.5 times 160, 0.05, sorry, I said the wrong thing. When you multiply that out, that will be 8 students who have red hair. Always remember the 5 things. You are lovable, valuable, changeable, forgivable, and never alone. I hope you're confident in the math. I hope you feel like you know what you're doing. More than anything else, I hope you know that I care.